We're going to, next speaker is Andy Penrose. So there was a change. I don't know if it's reflected in our speaker was in Israel and unable to fly out for obvious reasons. So thank you for Andy for stepping in. Dr. Andy Penrose. Right, I'll start the introduction. It's on the recording, so you have to be careful. Our next speaker is Dr. Andy Penrose from Cadence. He's in the Software Engineering Group Director. The title of his talk is Revolutionizing Verification with GenAI-Powered Automation, a paradigm shift towards agentic workflows. Andy is a Software Engineering Group Director in the System Verification Group at Cadence. During his 20 years in EDA, he has focused on clock tree optimization, SoC pre- and post-silicon debug, and now agentic AI for accelerated verification. Over to Andy. Thank you. Should be working.
Right. Thank you for the introduction. Good morning. Okay. So this is the obligatory forward-looking statement slide that I need to show. Before I get going, it is just worth reflecting that the pace of change around LLMs and agentic AI is so great at the moment that actually this is slightly more relevant than usual. And while I'm presenting our current plans, we will very much be staying alert and flexible as the technology changes at pace. So just bear that in mind. Okay, before I look forward, I want to look backwards. EDA's 40-year history has one of our key objectives in that history has been to improve productivity, to try and drive down those costs that we saw ever increasing in the previous presentation. So no more polygon pushers, no more transistor level layout. We've moved to RTL synthesis, high-level synthesis as the norm. And with LLMs, we see the potential now to drive the next level of raising that abstraction, using natural language as a key part of the design flow. Now, I'm not saying that system Verilog is going to disappear and be replaced by English. That's not that. But actually using natural language to interface with the tools, interface with the flows, and drive that design and verification. As well as raising abstraction, EDA has also given performance and productivity through excellence in simulation and optimization engines, the checkers, the solvers, and the like. And we've been infusing those with AI, both inside and outside. And again, we see a great opportunity there also to better use those engines, to connect them to LLMs, connect them to our agentic flows to improve performance and productivity. That combination of natural language interface and improved optimization AI is really what we see driving Cadence agentic AI as we go forwards. Now, it's fair to say we've been talking about AI in EDA for a while. So what's changed? What's new? Well, it's reasonable to say that hardware design tasks are more difficult than software tasks. So if we're going to use LLMs for any kind of hardware design or verification task, they'd better be pretty good at software tasks. Now, there are many benchmarks here. This live code bench is one of the newer, more difficult benchmarks. And if we look at last year's models, Llama 3, Llama 4, even DeepSeek V3, the non-reasoning version of R1, we see performances not great, less than 50%. And certainly last year, some of these things weren't looking like they were quite ready. But at the end of last year and coming into the beginning of this year, we see models like O1, O3 Mini, and DeepSeek R1, which captured a few headlines. These reasoning models, by spending a little bit of extra time in inference, a bit of extra thinking time, have really given a step change in performance on these software tasks, as you can see. And that gives us hope that then we can make use of that improved performance and start really addressing some of the hardware tasks, hardware design and verification tasks that we're interested in. Another thing that's changed is protocols. LLMs have had the ability to call tools for some time. But how do you interface your EDA tools with your LLM? And it was looking like we would be having wrappers here and wrappers there. And it just was feeling a little bit messy. And then along came MCP, launched at the end of last year, relatively quietly by Anthropic. And then suddenly, the thing that everyone was talking about earlier this year. And by using the Model Context Protocol, we've been able to wrap functionality within our tools, really provide an opportunity for agents to use those tools in a quite effective way. Now, I don't have a slide on it because it's too new, but actually, one thing we found is this is really promising. Being able to chat with the capabilities of the tools, not just with the tools themselves, but with the capabilities. If I want to find out how many counters do I have in my design? Well, for a small design, the LLM would probably get it right, but for a large design, it's going to get it wrong. But if we take Cadence Jasper, for example, that has the analysis capabilities to find those counters. Now, if the LLM knows how to use the tool and use Jasper to find the counters, we can start getting very reliable results through that natural language interface, and that's very exciting. I'm really looking forward to bringing that forward. As well as MCP, we have our agents talking to our tools via MCP. We also want our agents to talk to other agents. And there are a number of protocols here: agent-to-agent protocol, agent communication protocol, OpenAI have Swarm. There's too many to list. So that's definitely an area where we're keeping a watching brief and seeing what turns out to be the winner. So we build our agents talk to our agents talk to our tools. But also, another thing we're very excited about is actually having customer agents talking to our tools or our agents through these standard protocols. And the standard protocols make that much easier. So we accept that there will be customizations you have in your flow, areas where you know best how to write your agent. And you want to connect that to our tools, the functionality in our tools or in our other agents, and providing that, being open and providing that connectivity through to our tools and agents, we think would be very powerful, and we're looking forward to doing that. So with that said, what does the journey to autonomous design look like? So borrowing heavily from the overused automotive 5-level scheme, I want to work through those levels and talk about how we see that progressing. So with level 1, we have optimization AI. This is the AI we've already been doing. This is the platforms that you'll be familiar with, like Cerebrus and Verisium, using AI to optimize those workflows. At level 2, we have conversational LLMs. This is beginning to add natural language interface to the tools, how to make use of the tools, how to understand the functionalities and the operation thereof. With level 3, we had complex reasoning, and I'll talk more about that in a moment. With level 4, we had agentic workflows, not just individual agents reasoning, but collections of agents working together, breaking down big tasks into smaller tasks with expertise, with tools, and executing on those. And for the digital design and verification world, we then introduce our silicon agent as a means to perform macro tasks at a much higher level. Level 5 is full autonomy, and I'm not going to talk about that because it's too far away. When we get to silicon agent, we're not talking about a single agent though. As I say, we're talking about a hierarchy of agents. And one big dichotomy we see here is the split between creation agents, agents that are generating collateral, and execution agents that are running the flows. All of these integrated with and calling AI-enhanced design engines. And we see these working together. you generate some collateral, you execute the tool. Maybe the collateral wasn't correct, the tool throws in syntax error, but we don't need to give that back to the user. We can build automated correction loops. And that's shown a lot of promise. Interest of time, I'm going to skip that. So level 1, where we are today. So many of you will know the Cadence Verisium platform. For those who don't, or just as a reminder, key components are Verisium Manager, which does verification planning, regression automation, coverage closure, and compute resource management. Verisium Debug has high-performance waveform analysis, advanced RTL and test bench debug, and schematic driver tracing, among other things. The Verisium apps really split into compute optimization tools and debug automation tools, aiming to automate some of the more challenging parts of the regression management and debug flows. One other tool in the Verisium platform is SimAI. SimAI learns a model, works with your constrained random tests to drive equivalent coverage with much fewer compute cycles, and also with some enhancements we've made recently, can also drive coverage closure or enter a bug hunting mode, looking for and trying to exercise those rare bins and bring out the bugs that are otherwise hard to find. Looking forward, we get to level 2 in that automation, levels of automation. Conversational LLMs. So what do I mean by that? So the user gives a query. We're very conscious that our tools have a lot of functionality, and even experts in the tool may only know some small part of that functionality. And finding out how to do things that you're not familiar doing can take a lot of time. So rather than sift through documentation, just ask. That query is then going to go through to the Cadence GenAI library, which will pull in information from various sources. Product documentation, app notes, racks, troubleshooting guides from the Cadence online support system, which is now Cadence Ask. And also maybe customer knowledge sources. So if you have particular knowledge sources that you want to plug into this, that will also be possible. The system will then take all those knowledge sources and come up with an answer to your question and give that back. And we find that can be a much quicker way of working out how to do things in the tools than before. But level 2 is really a stepping stone to level 3. I'll come to in a minute. Sorry, I meant to give an example. How do we know this works and works well? We find VIPs require support. Our verification IP products model very complicated protocols, and there's often a lot of questions about how to use them, how to configure them, and what a particular error message means. We've been working with internal experts using this technology to make sure that we're giving good answers, not just answers that sound plausible, but answers that experts in the field, experts in the domains are happy with. Combining both the VIP documentation and also system Verilog building blocks to help give examples for how to configure the VIPs. Now, as I was saying, level 2 is really a stepping stone to level 3. Rather than what is the command to do something, wouldn't it be better to say, give me a tickle script to do something? Or better yet, just what is the result? So by combining those knowledge sources that I talked about earlier and adding in a bit of reasoning, using the tools to evaluate and execute, maybe do syntax checking, using APIs, we can get to a next level where the automation is providing scripts, or as I say, the answers to those questions. And this is then built on the functionality we have within the GenAI platform, both retrieval augmented generation and foundation models, including reasoning. I'd just like to give an example of that. Before I go through this example, one other thing that we've come across is a real desire to have some of this functionality in a new area, to have this functionality in VS Code. And why is that? Well, Jasper, for example, is a great engine for proving properties and investigating complexities, counterexamples, and debugging. But it's not where you build your formal environment. Likewise, Excellium is a great simulator, and Verisium Debug a great debug platform, but it's not where you build your test bench. These environments are actually built within an IDE. So we want to bring these generative and agentic capabilities into the IDE to meet the designer, the verification engineer in that environment so that we can accelerate their work and not just provide these in the tools that we already have. So in this example, you'd be building your formal environment. The prompt starts with a description of when to count packets as pending, when packets are no longer pending, and a request for a cover. Let's make sure we cover the case that we have 2 or more pending packets. So this is the chat pane on the left, and because this is VS Code, it's very easy to move the generated code into the formal environment that you're generating in an editing pane on the right. So this property requires some auxiliary code, which was generated, and then a property that was, again, generated and moved across. As we move forward, we can begin to integrate more reasoning and more tools. So has the property that's been generated syntactically correct? Okay. Let's run it through some lint tools while we're at it and provide just a slightly better output as we go. Now, as I said before, we're not at full automation, so anything that we generate really needs user review. And we can help that review process by providing some explanations. What have we generated? What are the system Verilog constructs doing if we've used an unfamiliar construct? And particularly for junior users, we hope this will be helpful to explain what's been generated, and also just to put forward that thinking process of whether what has been generated not only matches the intent, but whether the intent really matches what was necessary at the time. So by providing that, we aid the review process. So that was level 3. Moving on to level 4, we need to do more and generate more. And this brings us to our spec miner project with spec analysis, verification, and test bench generation. So this follows the standard spec first verification flow, where we take a spec and verification collaterals, feed those to verification agents, and look to generate things like verification plan, test bench, and ultimately executable spec. On the left-hand side, we have the SVA generation. As I showed on the previous slide, we've integrated that with VS Code. We also have an integration with Jasper that's in testing. On the right-hand side, we have test bench generation, which is slightly more of a work in progress. This starts from the spec to generate a plan, and from the plan to understand the interfaces, gather any missing information, and then either for formal or for simulation, similar flows. We need to configure VIPs, create test infrastructure, create test properties or scenarios, prove those properties or run those tests. Potentially then, as we run, either automatically fix syntax errors or make suggestions to the user if we cannot fix them. Maybe do some initial debug. And having run the tests, obviously analyze coverage and begin to do some initial automated coverage closure. These are all things that we're looking at and building towards. Everything, test plans, test benches, formal environments. Okay. So how do we see all of this coming together? So we start with creating. So we assist in that creation process with the agentic AI, building, taking specs, and it says chat here. I mean, conversational interface. It's a conversation between the user with the specs and the system to build verification plans, assertions, cover points, test benches, etc. To then run that with Verisium Manager to run those regressions, analyze the results, drive coverage closure, and to have the user or later agents use the Verisium apps to go through the debug process and resolve regression failures. Now, it would be wrong to say that all of this is straightforward and not without some challenges. I would like to reflect on the challenges briefly. One is scaling complexity. I've seen a lot of great demos that start with a FIFO. And indeed, people will often say, but ChatGPT can do this anyway. And for a FIFO, absolutely it can. Generate the design, generate test benches with good examples. Straightforward. But there are a lot of EE 101 courses that start with how to design a FIFO that are online. And simply that won't scale to real interesting examples. So we need to check that we're actually scaling properly. I think the new reasoning models really help close that gap, as does using systems of agents to break down the bigger tasks. That's something we need to be aware of. Preventing auto-accept. In the automotive sense, this is what is the EDA equivalent of please keep your hands on the wheel? As we're not at level 5, we need some user review, and we need to make sure that the user isn't just clicking auto accept as we go. And as the ability to generate, as the generator becomes able to generate at a much higher volume than the user can easily review, this becomes a real challenge and something we need to work on. And also, automated evaluation is hard. As we build EDA tools, we want to make sure that every release is at least as good, and hopefully better than the previous release. We run benchmarks, we check runtime, we check PPA, we check all these regression tests. These agentic systems and generative AI in general, how to benchmark it. There's many ways to generate an acceptable test bench for a given DUT. For SVA generation, there are actually some quite good benchmarks. But for some of the other use cases, the benchmarks are much less sophisticated. Actually, since I wrote this slide, I've just come back from DAC and the first international conference on LLM-aided design last week. And there's a lot going on there in terms of benchmarks. There's a lot of work on providing better benchmarks, less trivial benchmarks for interesting cases. So actually that is something which is moving forwards apace. Then one final challenge that's not on the slide that I'd like to leave you with is simply compute. If you or your manager or your executive sponsor is keen to evaluate these tools as soon as they become available, I'd encourage you to think about how are you going to connect that to an LLM. If you have on-prem GPU, great. We can install our JEDI platform, run an LLM on that on-prem GPU, connect our agentic applications to that, and have that running. If you have a cloud-provided LLM service, GPT or the O1 models in Azure, Gemini on Google Compute Platform, something like that, again, we can connect to that. Our agentic applications don't mind where the back-end LLM is. They all connect through the JEDI platform. If you don't have a cloud-provided LLM that your InfoSec people have signed off, or you don't have on-prem GPUs, now I would encourage you to think about how you're going to achieve one or the other of those, because without that, it's very difficult to move forward with any of this. And that's something we've found as a challenge moving forwards. And with that, thank you. Any questions?
Yeah, 5 minutes for questions. Just put your hand up and I'll dash to you with a mic so we can record the question. We have some online as well, so I can kick it off online. No. Right, Andy, if you just say your name as well, Julian.
Of course, mate. Hi, Andy. Julian Lonsdale, First EDA. Thanks for the presentation. How much of the AI-based fabric currently is cloud-based? And from the point of view of you guys being very aware of data security for your clients, what's the general kind of structure and architecture of that capability?
Okay, good question. It is something that people are often very keen to discuss. So as I was just saying, on-prem or cloud, we support either. So if you want to be fully on-prem, then you need GPUs to run LLM services, but that's going to be something that you need anyway if you're going to embrace the technology at all. If you have a cloud system that your InfoSec guys have signed off on, then that works too. So we don't mind. Nothing comes back to us. So it's all either on your premise or within your secure tenant on whichever cloud provider is supported. So none of that comes back to us. It's all on your environment one way or another.
Yeah, Andy Bond. So having been down this route with UVM, ERM, and then UCIS and everything else, it seems like the inferred data is going to be a big company benefit that you need to maintain and transfer. How are we going to avoid having to reconverge on a standard across EDA when the inferred data becomes a key data set for everyone?
So I think you're sorry, just to rephrase that question. I think your question is, how do we deal with data scarcity?
So with everything over the last 20 years, we've ended up with all the ED vendors coming up with their own solution and then eventually converging to be a combined solution to enable transition and to actually allow you to take customers off other vendors as well. All this inferred data, so everyone's doing their own bespoke thing. Are we already planning to come to a system where we actually do have interoperability in the future, or is that tomorrow's problem?
So the interoperability question is a good one, and very, very aware that we are not the only EDA vendor, and that a certain amount of interoperability is expected and required. And it's an interesting challenge. But I think, and if you'd asked me a few months ago, I would have probably ummed and ahed. But I think MCP is actually looking like something of a game changer, as it gives us an opportunity to provide an interface, a protocol to provide an interface, and then how that's implemented behind doesn't matter. So model context protocol is all about providing context to models. So how that data is organized behind the MCP interface, it can be whatever, as long as it's provided to the LLM through that interface, then we can make use of it. So we see that as a great opportunity to be flexible, to work with customer solutions, third-party solutions, and to integrate those in flexible ways for whatever system you want to build.
Thank you. Yeah, so I guess you're talking about an API. And I think these things lend themselves well to industry collaboration. I'm going to point to Charles, who's busy on his phone, Charles of TechWorks, who are putting together a verification forum as well. So Charles is going to speak about that later when he stands up. But visit me or and Charles happens to be next door on the TechWorks stand. There are industry verification forums where we can discuss this. And I think what we're hinting at is rather than a data standard, an API standard, which allows people to be flexible in the background and innovate on the data structures, but not on the API then. Okay, and that's a good way of doing that. And given data is the new oil, I think there's a lot of money to be made out of those data sets. Okay, and I think also we recognise it will be holding back our industry unless we can share data. It's long been recognised. That's a good place to finish. It's now break time. we are going to be very strict with the time. We do start on time. And in the next event, you'll notice we go 20 minute, 20 minute, 20 minute. And you can switch between them. But everybody sticks to 20 minutes. And we do start on time. We will finish on time. So you can get your lunch on time as well. Okay, perfect. Thank you very much to Andy. Thank you very much to John. And enjoy your break, network, go and see our sponsors.